This is Dr. Carroll, and this is another recursion example that I'm going to walk through. This example is about Euclid's algorithm to calculate the greatest common denominator. And this is a classic textbook example of recursion because it shows how beautiful recursion can be. And it also is kind of mysterious, so it's helpful to walk through a mysterious program and peel back the layers and see what's going on. So let's look into this. So it's a recursion example. I wrote it. This method GCD is the Euclidian algorithm for calculating the greatest common denominator of two numbers. Okay, the A is one of the two numbers and B is one of the two numbers. And so what we're going to return is the greatest common denominator of A and B. So in case you've forgotten what that means it's the largest number that divides both A and B with no remainder. Okay? So let's skip over it for just a second. Come down to main here. I've hard-coded 3 examples. 10 and 8, 108, 8 and 100, 213. Okay? So this one is saying, okay, 108, what is the greatest common denominator between them? Well, it's not 8 because 8's not divisible by 100. And so we'll see that it turns out it is 4. So then we're calling it, getting the result, and then just displaying it. So coming up to this recursive method, it's static just because I'm showing it just with a simple call to main, so we have to make it static. It takes in longs just to show that this can be really big numbers, and so potentially it could return a big number, but you can think ints if you're not as familiar with longs. This is just to display a call to it to help us keep track of what's going on. Then here we have the base case. If it's 0, then we're done, and A is the greatest common denominator. Otherwise, look how simple this is. We call greatest common denominator, this function again, but we pass it B as the first argument and a remainder B as the second argument. And then whatever this returns, we return here. Now, what I want to do first is let's step through and illustrate what's going to be executed. So I'm just going to kind of break some rules here, and I'm just going to copy and paste the lines of code, which isn't exactly correlating with the instructions, but the lines of code that are executed. So the very first thing that's executed is main, and we do something with arguments, but we ignore it. We're going to declare a whole number, a long, num1, assign it 100, num2, 8, and then we're going to make this call. Now notice it's a call here, and so let me comment out the first part here because the commented part is going to happen later, but this part is happening now when we're calling it. So I'm just recording what I'm showing here, something very different. I'm just going through step by step how it would be executed. Okay, so let me split the screen here. And so then the next thing would be executed would be here. We're going to call this method. And so this is just a placeholder to say, okay, we're copying num1 into A, num2 into B. And for simplicity, to really help learn this, let's just record what's going on here. So A is 100 and B is 8. We're going to display that. And then we're going to come down here. Now we're going to test if B is 8, which it's not. And then we're going to skip over that. And we'll throw in the else just for simplicity here to keep track of what's going on. So we do else, and then we have a return and we're calling it. So let's comment out the return, because we're not doing that right now. Indentation's going crazy here. Sorry. We're going to now call this method again. And what are we going to call it? We're going to call it with the arguments 100 and 100 remainder 8. Let's see, 8 goes into 196 evenly, and so we have 4 left over, and so we're going to pass 4 to it here. So what we're going to end up doing is we're going to end up calling this method again. And now A is 8 and B is 4, because that's 100 mod 8 results in 4. We're going to display that, and then we're going to test if B is 0. It's not, so we're going to come down to the else, and then in the else we're going to execute the return. And so we're going to end up calling this method again. Oh, let me scroll up so we can see all of them, see the progression just a little bit better. So we left off right here. We need to update these. So now A here is what B used to be. And now we had 8 mod 4, 8 mod 4. 4 goes into 8 evenly. So there is a remainder of 0. So we display that. We display B equals 0. No, actually, we do the base case. I'm going to leave this comment in here just to help see where things are. And then finally, we return A. Finally, we return A. And so now what do? Now we're going to return, and we're going to return to here. And this is when A was 8 and B was 4. You could put that in there. Now we are returning this value because that's what they were, and now we could say returning 4, because that's what we're doing. Now we are finishing up what we had started, and what does that return to? That returns to this call right here, where this is from when A was 100 and B was 8. We are now finishing up that call, and what's it going to be? It's going to be returning 4, because that's what this returned here. We passed it to here. Okay, so where were we before that? That's going to go back to here now. And so assigning 4 is what we're doing here. And for completeness, then what we would do is we would display this. Okay, so this is just a trace of what's going on. Now let me show you a different way, because recursion takes a little while, I think, to wrap your head around. So I'm utilizing here javatutor.com/java.html, and I have pasted in the exact same code here. And what I'm going to do here is use this as a visualization. So here is the red pointer. This is the next line to execute. The green arrow we'll see is a line that just executed. So again, we start in main. This is just what I showed, but a little different. Num1, so in our stack frame here, we're building that up. We're in main, and this number shows us what line were we last on when we're doing that. So we've defined these, and now it made a call to greatest common denominator, GCD, and it passed in 108. So it pushed this on the stack frame. We called this. This is just like what we've seen before with other call to functions. We display it 108. It's not the base case. So now here's where it gets a little tricky. What is this doing? We're calling this method here. I guess it's a function because it's static. You could look at it either way, but we're calling GCD from GCD. Well, don't let that trip you up. it's just like any other function call. We keep where we were, and then we call it. And notice where the arrow goes. We took care of this, and now we're ready to display this. And we have a second call to GCD, but here A for this call is 8 and A is 4. We still have this on the stack frame, and so there are two A's that are completely separate. One has the value of 100, one has the value of 8. And so we're at the second call, too deep here. Go in and we display this, and sure enough it says, hey, I'm calling GCD again with 8, 4. We're not at the base case, so what do? We call it again. Okay, and now notice it put another call to GCD on the stack frame. And then we call GCD. This shows that we're calling GCD. Now we are at the base case, so we return A, and where do we return it to? We return it to where we were with this stack frame. So we're going to return A, and we're going to return it to another call to GCD, and it'll be right here, and returning it. So here we go, return value 4, and we came back to this stack frame where A is 8 and B is 4. Now we're returning 4, and it puts that on the stack frame so we can return it. We return it to where A was 100 and B was 8, and then we return from there 4, and then that returns us to our initial call of GCD. So result now is 4, and it can assign that and display it. Woo! Okay, well, that was fun. Let's do it again. So now let's set 8 and 100. Notice what happens here. We make our first call to GCD. Not a big surprise there, 8, 100. And notice what we do here. We make a call to GCD, but it changed the arguments. Well, look, these match up perfectly. We've already seen what happens with the call 108. It doesn't matter that we're one call deep into it already. We know that what's going to happen, because if you call a function with the same arguments, we already know what's going to happen. So we can go through this quickly. Sure enough, 8, 4, 4, 0, and then we start to return. And so we had a couple more frames. We had one more call to it. Now let's see what happens when we have to keep going. So 213 here. Okay, we make our call. It's not the base case, so we copy 13 into, we call it with 13 and 200 mod 13, okay, which is 5. We're cutting it down quickly, and we display that. Not the base case, we call GCD again, display. We're now at 5.3, we're getting closer. Keep going. We're now at 3.2. We're now at 2.1. And notice we make this call inside that call. We made that call inside it, and it keeps track that we're at line 26 in this frame, 26 at this frame, 26, 26, 26, and then the current one we're at 20. Finally, we get a call 1, 0, so then that triggers the base case. We're going to return 1 because the greatest common divisor between 213 is 1. They don't share any larger number. And so we're going to return 1 to this, where we were with this frame. And then that's going to return 1, and that's going to return 1. And as we keep our pointer here, and then that finally will display it that it is 1, and we are done. And we return from main. I hope you enjoyed that. Maybe play through it again. Feel free to copy the code into pythontutor.com/java.html. Click on Visualize Code or Visualize Execution, whatever the button says, and watch it for yourself. That's it for this video.